I'll start timers.
Okay, we're gonna do this. We need to click.
You can never tell Spencer to shut up too often. Yeah.
Why don't you have them?
We should ask the secretary.
Yeah. I can click.
Huh?
It's Gregory Bell.
Excellent. Welcome to PANRG. If those of you who have laptops could please open them and find some high CPU workload to start running. Maybe we can get the temperature up in here. I didn't say waste power, I said warm up the room. Are you allowed to run Chrome? Are you allowed to run Chrome?
What is this program?
Wait. Why is the name speaking about things you have no idea?
Yes, I have a copy of Chrome.
What is Edge?
Okay, so I'm struggling to get it to fit properly on the screen. It's not perfect. For some reason, Spencer slides look better. Anyway, I think that's good enough.
Uh-oh, Chair is watching. Come on.
That helps.
Come on. Recover.
What did you do last night? Yes.
It's in the agenda.
Yes, thank you very much, Tim. Yeah. Yeah. Hello, everyone. Welcome to PANRG. I think it's time to get started, yeah. Note well. I'm getting back. I think it's the right note well this time. So you might not have seen that before, because it's the first time I put the right note well on the slide. So you might want to look at this. We need a JavaScript. Oh, good.
You guys can fight each other.
Yeah.
Go for it.
Okay, great, sorted. So, agenda. We have full agenda. So I'm not even going to ask for agenda version because I assume we don't have time for it anyway. If you have any suggestions, we have not filled agenda for the next meeting yet. So please say your name and the microphone. It would help. So we have almost the same list of documents as the last time. So we have 2 active documents, and we're going to talk about both of them today. And we have 1 individual draft which Teresa is presenting. And we have 1 individual draft which hasn't been updated since the last meeting, but I still keep it on the slide. So, and now I think, Brian, let me switch to, just a second.
This microphone is not battery. So
You can use one of those maybe. Oh, yeah.
it's not. I'll just.
It's more important to not be from the chair than to. I will. Yeah. Thank you very much. I will do this from the floor. Hi, Brian Trammell with a question about this document. So yeah, this is IETF PANRG questions 02. Basically in Prague, we discussed this, we went over it. I decided actually not to bring this back up on slides because there have been no structural changes to the document. We got good comments from Mohammed Bukader. I don't know if he's here or not. We brought those in. That was the 02. It came out in May. mainly, and we also had a discussion about whether or not we wanted to keep this document open as a living doc, sort of as the framework of what it is we do in here, or if we wanted to go ahead and publish it as a snapshot in time. And there was kind of a lot of discussion from the floor where we said, hey, yeah, no, we do actually want to keep this open. As author, not as chair, I would push back on that a little bit in that if you want to look here, right, like so there was draft TRAML-PANRG questions and then draft IETF-PANRG questions. And basically what happens is we're updating this infrequently enough that it's expiring, which kind of signals to me that it's not really actually living up to our expectation as a living document, right? Like, so a living document that is dead is an undead document. Draft IETF-PANRG zombie questions. So I would actually, as author, come back and push back on that a little bit and say, hey, if we're not updating it that quickly, why not just publish it? So not to sort of like relitigate something that we already talked about. If there's not like, strong consensus that no, keep it open because we might think of something, I would say, hey, maybe we should just go ahead and push this one out. So I guess now I would ask the chair to open the sort of questions or discussion about that. If anyone cares, we'll do it. If no one cares, or if anyone cares, we won't do it. If no one cares, we'll do it.
If you turn around, you can see there is a line for the mic.
Hello, Aaron.
Perhaps a title change, Open Questions in Path-Aware Networking in 2019 or something like that.
Yeah.
Then you can publish another one when you get more questions.
Yeah. That is an excellent suggestion. Thank you. Wow, we're going to update the document without letting it expire.
Spencer Dawkins. So I wanted to mention that I'm expecting to make references to this document in my second presentation today. So after I do that, you might want to decide then whether you think it makes more sense for me to be pointing to it as a draft or as something that you've requested publication for.
Cool, thanks. Actually, just out of curiosity, can I see a show of hands? Who's read this document or some rev of it? Okay, cool, good. Those of you who haven't read it, please have and are interested in the space and are not just sitting in here because it's a nice place to cool down. Please have a look at it and give comments. Hey, yes, I think this covers the questions that we care about. Oh no, have you thought about this question? Because like a lot of these revs early on, we actually did rev it because people are like, did you think about that? No, we hadn't. Let's put it in. Did you think about that? No, we hadn't. Let's put it in. But we haven't added anything new, I think, for a year at this point. So please do have a look at that. I'll think about the right way to incorporate Aaron's title into that. Yeah, let me think about that. I'll definitely change it. I'll definitely make it not like, open-ended, because you're right, this sounds very open-ended, and if we're going to publish it, that's paradoxical. I'm not sure I want to put 2019 in the title because it's not my favorite year, but yeah, so thank you very much.
Okay, no more comments? Okay, that was quick. So Spencer. Yeah.
Yeah, keep in mind, actually, you're going to have to, there's no cable on this that we can possibly do. That's the same. Oh, battery's off, cool. Does that work? No, not yet, but it will in about 30 seconds, or less. Yeah.
You can use the voice interface.
Ooh.
Yeah, this is the thing that always terrifies my kids. So I'm Spencer Dawkins to talk about the research group draft, what not to do, -03 revision now. And I want to talk this time mostly about what still won't work. So here's what's happened since -001, which was the last IETF revision. IETF meeting revision, and I've gotten new comments thanks to the people who sent comments. I'm getting careful reads, but I'm not getting a lot of new material. So I'm getting helpful suggestions. I'm getting typos. I'm getting this is unclear, but I'm not getting new sections or supporting new lessons learned. So we might be finished with this one. Research group last call ? We can talk about that. We can certainly, my opinion, we can certainly use 03 to guide our research and to start discussing with the IETF, and I actually mentioned that in a side meeting this morning, this draft that the research group had been working on. So my suggestion is to review the lessons learned and see what's still true because things change. That's what I'd like to focus on in this talk. Not wordsmithing. I'm happy to wordsmith, and I've gotten pull requests, but we do have a mailing list and GitHub for that. This is kind of the are you out of your mind review by the research group for Spencer. I have blue boxes. I have suggested answers for whether each lesson learned is still true in blue boxes like this one. These are only my opinions. There is a mic. There are mics on both sides of the room. I hope to capture your answers here and on the mailing list in a -04 revision. So the unsummarized and annotated summary of lessons learned that's in -03. Overcoming entropy. If it ain't broke, don't fix it. I think this one will always be true for path-aware networking and probably for everything else. Objections? I'm seeing thumbs go up, and I'm not seeing anybody diving for the microphones. Next, providing benefits for early adopters can be key. I think this one will also be true for path-aware networking and probably for everything else. Thumbs up, thumbs down. This could be very Roman. Okay, I'm seeing some thumbs up and no thumbs down. Yes? I should be letting you call these. Okay, an individual thumb. Awesome. I should actually probably be letting you all call the thumbs. I can do it? Okay, cool. Whoa. Here we go. So I think this one is also true for path-aware networking and everything else. The thumbs have it. End-to-end mechanisms may respond to feedback quickly enough that the additional realizable benefit from a new path-aware mechanism may be much smaller than you thought it was going to be. This one, in my opinion, is worth talking about. It's one of the key debating points for the loops BOF that we held Monday, I think in this very room, if I was remembering right, but they all kind of look alike. And a great deal has to do with whether there is more than one long path segment in the path. Thoughts on this one? And this is not a thumb question. It's actually a brain question. Any thoughts on that? Or, I mean, you could say, yeah, we need to think about this some more. Does that sound right? Okay, now thumbs. Do we need to talk about this one? On mailing lists or wherever. And I'm seeing Tommy is diving for the microphone. Good job.
Tommy Foley, Apple. I was not at the Loop SPOF. Would it be possible to kind of cover what the highlights?
Yeah, so it's basically the classic discussion that we've had since at least the TrigTran BOF in the early 2000s, which is basically you're going to add complexity to a probably complex transport protocol in order to improve performance. Are you going to get enough new performance that, in the quote for TrigTran was, can't you just burn a couple of round trip times and you'll be in the same place as you would be with the new mechanism? And all you'd have is you've saved a couple or two or three round trip times, and you have a more complex implementation that's likely to be slower.
Hi, Brian Trammell, individual. Actually, Spencer, I have the PANRG chair hat, right? Can I get that from you? Did you bring it?
I'm
So I can put
getting
it on and
it
off.
now.
Yeah. Cool.
Don't wait.
I think I'm looking at Teresa here because I think that this, like, the difference between a property for which you're going to get a realizable benefit. So this is not wearing the chair hat. The properties for which you'll get a realizable benefit from path-aware networking are qualitatively different from those to which this question applies, right? So this question is about, like, hey, if we get the devices on the network to tell us things like, queue occupancy and delay, we're not going to get data back any faster than we would if we tried to measure it, right? And that's true, and that remains true. There are the set of path properties for which you get an immediately and scale is the wrong word. For which this really helps are things that are difficult to sense and change slowly. So to the extent that we think that there are a large set of those, then path-aware networking is a great idea. To the extent that we think that set is empty, then this question applies. I would flip this question around a little bit, right? And basically rephrase it in terms of the meta properties of the properties that you're talking about. Path RTT is a terrible property to use path-aware networking for if you're actually talking about having the path tell you things about path RTT, because they don't know it and it'll get to you too slowly.
Yeah.
This is a satellite link. Satellite links usually do not turn into non-satellite links on, Elon Musk notwithstanding, on a very short time scale. Maybe you can sense it. Probably you can. So this is like, question to the research group to think about, as well as I think feedback on the document. If you split that question up, then the loops question goes away, and then we have another question that we can dig in on, but I don't know the answer to, but.
Okay, excellent. If I could make two.
Tommy's coming up.
If I could make just two quick comments here and then let Mr. Tommy take it away. So the first thing I'm thinking is that we may end up with a -04 that has new subsections for some of the lessons learned, but not all of them, because they're true for all time and space. And that's where we might put discussion about things like that. And the second one was being clear that we're talking about relatively long-lived and stable information about the path that isn't easy to find out and isn't easy to and doesn't change rapidly. That's both captures yours. Okay, excellent, cool. Tommy.
Hello, this is Tommy Polly, Apple. So I definitely like Brian's suggestion of changing how we phrase this particular lesson. Mm-hmm. So I've read the document before, but I've had a nice little break of like not reading it for a while to clear my head. And so just looking at it again, this discussion I think helped make it much clearer, the point you're trying to make, than when I went through that original text here.
Yeah,
and
thank
maybe,
you.
So I think one of the things that's confusing to me initially on this is it's not really giving us kind of like the lesson learned. It's just saying that this may happen. And so maybe can we add some qualitative way of saying, like, these particular mechanisms that behave like this end up being more useful along this axis. So
yeah.
Tell what is it about it that makes it better or worse for this quality?
Yeah, thank you.
Teresa Enghard, following up on what Tommy and Brian just said, I wonder, for example, if we can say if the endpoint is in a worse position to learn about like some RTT or some properties than the path itself, then it might be helpful, or like in what case might it be helpful? Well, if the path can tell the endpoint something the endpoint cannot measure by itself, for example. So that would also help me to think about this question.
I think you'll like my next presentation. The others? So I think I know that we're doing something with this lesson learned. The follow the money, I think, is always true. That basically, if you can't, your choices are basically either you get a lot of money from deploying this or you get a lot of benefit from doing this. At least one of those must be true. Thumbs up, thumbs down. Seeing nodding heads, seeing thumbs. Okay, cool. Operational practices can be showstoppers. I think this one is worth discussing, not because operator motivations and behavior have changed, but because we keep coming up with new ways to mask protocol mechanisms from analysis by middle boxes. I had text in there about, so why was shim6 a train wreck, but in multipath TCP wasn't the same jumping up and down at Nanog screaming at the IAB member who was presenting it kind of experience. But I think we're headed that direction towards thinking more seriously about operator behavior in a newly encrypted world. This is my opinion, and I'm pointing towards things like the invariance and quick, and you don't get to know anything else as an example there. So this might not be as true in the future as it has been in the past. Brian, without the incredibly cool hat.
Without the incredibly cool hat. Hi, Brian Trammell. This is another one that also I think is a flip side, or has a flip side. So impact of a pathware technology requiring changes to operational practices can prevent deployment of a promising technology. Impact of pathware technology enabling changes to operational practices might be an incentive. I don't know how to capture that really in the tone of this section. But for example, one of the, looking at Scion, for example, as a pathware architecture, one of the key things that they have heard, and one of the key, like, hey, here's why we think we can actually get operators to care about this, is interdomain QoS, right? It's like, here, look, it changes your practices, and that practice is, here's a new service you can offer. Will it work? No idea. But does it incentivize people to try? Yes. So I would possibly rephrase this one slightly to capture the fact that this goes up and down. I know I just said interdomain QoS in a room in a building where the IETF is meeting, so I will sit down now.
Cool, thank you. So that's the incredibly cool Brian Himmel without the incredibly cool hat. So this one we'll be talking about some more between now and IETF106. Per connection state, again, I think this one may be worth discussing because we've usually talked about this in a please don't do this in my core router int-serve context. And enough people have scolded me saying access routers or enterprise routers may do just fine with that, to where it's worth being measured about the way that we say that. So like I say, just kind of making sure that we're stating that accurately for the way things work today. Yeah.
Eric Kinnear, Apple. It seems as though the problem isn't that an intermediate device might have per connection state itself, but what it might do with it. And so at that point, we kind of end up in this tautology of like, yes, if it does a bad thing, then that's a problem and it does a bad thing. So maybe would it be worth rephrasing it a little bit more as saying, here are either the kinds of things you shouldn't do, or like, if you do have per connection state, here are the things that seem fine to do with it, and kind of phrase it as a, like, not quite a behavior guideline, because that's not quite what we're trying to come up with here, but like something in that area, as opposed to just like, yes, per connection state could be a problem. It could also not be a problem. Sure.
Yeah, and try to, like, again, try to be measured about it. I think that, this is one of the things where this has been a electric, a third rail for a long time, and we have a lot of experience with it being a problem and not a lot of experience with people trying it where it might not have been a problem. So I think being measured again is a good thing to say. Yeah.
I was also stepping back a little bit and thinking about this from a little different perspective. I would say that adding new path elements or new network functions to a network could enable this kind of per connection state not on the router, but on some side you are sitting next to the router. And I think future architectures might really make this feasible. While all the years ago we find out it isn't feasible, it might just have become feasible now.
Excuse me, your name, please.
Philip Teasel.
Thank you. So this one we need to talk about a bit more between now and 106. In-band mechanisms can follow the fast path. Same response here, I think, which is basically there are people that aren't as worried about this as the people were worried about when they started talking about nice long IPv6 extension headers or deep packet inspection on routers, or things like that. So again, I think this is one that we'll be talking about between now and 106. Can the network path trust the endpoints? I'm going to talk more about this in the next presentation, but is there anybody that thinks that we don't need to talk about this? The incredibly cool Brian Trammell is coming to the mic.
I'm actually not sure whether or not I'm doing this with my chair hat on or not.
He's wearing
so
half the chair hat. I'm confused.
So I will point out that I know that right now in SAG, right over there, they're having a talk about a potential discussion about reopening the internet threat model and maybe trying to update it to talk about stuff that we know now. And this seems a little bit like, this is not the internet threat model. This is the path-aware internet threat model. But it seems like that discussion and this discussion are maybe kind of the same discussion. So the conflict is unfortunate. Yes, we absolutely need to talk about this. I'm going to go sit down and think about that for a bit.
Yeah, and I think my response might be that it's great that somebody is doing that, and it's great that it's not us.
Igor Lubashov. So it seems that the question here is, can the network path trust endpoints if the endpoints have no incentive to be truthful? Some of the signals can actually be beneficial to endpoints that are truthful, and those should probably have much more trust afforded to them.
Cool. Yes, thank you. And this gets us to the can endpoints trust the network path? So this is the other side of that, and that's got stuck on the following slide because the lesson learned was kind of long. But again, my opinion is we absolutely need to talk about this. So we need to, I think Brian's point, as I understood it, was we need to figure out how to talk about it. Not in the middle of the SAG discussion. Yeah, exactly. Yeah, exactly. We need to be aware of the threat model discussions. Cool. Can the network provide actionable information? So this is basically the distance and time to respond kind of things. I think that this is actually even more true now than it was in the cases that we've got in there, but I think it's probably always going to be true for path-aware networking and everything else. Yes.
Hi, Brian Trammell, individual. This is the same question as the first question that I came in to talk about, right? Like it's the flip side of the same question of if the information is available through measurement as opposed to from the path, why get it from the path? I'm not suggesting that you reorganize the document around that, but you making it clear in the text that this is the same thing is possibly useful.
Brian, this isn't much re-architecting the document because there's basically one section that has all the lessons learned in it with no pointers into it. So you win.
Teresa Enghard, just my 2 cents. I think there's both the point of knowing about the properties of the path and then doing something with it. And I think both questions had kind of both elements in them.
Excellent. Thank you. Thank you both.
+1 to that.
Cool. Do the endpoints know what the path needs to know? I think this is true for path networking, path-aware networking, and for everything else. We had, yeah, so this is 2, and I actually, we were in the APN 6 side meeting this morning, and I was talking about, they're talking about basically applications signaling the network, and I was like, I'm not telling you need to be in PANRG, but I'm telling you that we have concerns about applications knowing what they need to tell the network and being able to tell the network. So I think this one is true forever, and I think this one is true, I think slide 15 is true forever, and I think that slide 16, letting taps run for a bit and finding out what we do with APIs, are able to do with taps APIs may be a good thing. Lars is in here or not? Lars was telling me that he's having, he was having trouble figuring out how to do anything with ECN and Rust. I mean, it's like, so I mean, it's like things may be getting more broken as people are doing things that aren't necessarily sockets. So assuming that this is gone well so far, so this is 8 minutes left into my talk. We still have some questions about some of the lessons learned, and we've had more discussion about that here, and thank you for that. We can investigate those questions about our lessons. I would assert, speaking of Spencer, that we can begin to use the lessons we've learned to guide our research. There are relevant questions in the research questions, open questions draft that apply here. And we might talk about how the IETF hears about our lessons learned. I don't know that we're ready to inflict our wisdom on the IETF in any meaningful way yet, but something to think about. And do you think we need to talk about that here? Excellent. Okay. Brian with the incredible cool hat says we don't need to talk about that here. Thank you. So we've been discussing as we went through. Is there anybody that has food to throw? Or I can get to my next cool. Oh, there's more? Yeah. Oh, yeah. There's other presentation. And if you will cue that up, and if you will flag me down at 10 minutes and.
Before we go ahead and cue it up. So just again for the edification of the chairs, could I see hands for people who've read one of the last 2 revs of this document?
And it's fair to ask anything after -00 because they hasn't changed a huge amount.
Yeah. Okay. So I hope to see more hands than that in Singapore. Please go have a look. Thank you.
Yeah, think what Spencer is capable of when he has access to GitHub and no adult supervision. So I wanted to talk to you all about path implications, performance implications of path characteristics. And I was interested in talking about the PILC link characteristics experience. This is some information about that, and that basically the IETF did recommendations for subnetwork designers a long time ago. We think the internet may have changed somewhat in the last 15 years. We had a side meeting to gauge interest at 104. I sent notes about that to the PANRG list, and we had a side meeting here to identify recommendations that we were ready to make to the IETF about path awareness. I publicized that to the PANRG mailing list with not enough warning, and that's okay. That may be okay because we're talking here. Trying to answer the question, are there recommendations we're ready for the IETF to consider? And we did this yesterday morning. I have good news, I have bad news. The good news is that smart people showed up to help identify what's researched now. Thank you, the people on here. I think I got everybody's name, but thank you for the people on here who showed up. And if I missed your name, please let me know, and I can fix the slides before they go into the entombed proceedings. The bad news is that almost everything is still research. Oh, noes. The question, somebody asked the question in front of Lars, what could we tell the quick protocol, transport protocol designers? And we all kind of stared at each other. So I'll be back to talk about PIPSI when we have recommendations for the IETF, but the discussion was pretty relevant to PANRG. what I'm presenting now is my take on yesterday's conversation. Corrections and rebuttals from the people who are there are welcome, of course, either here on a list. What I would like to do is do this as a short rant followed and leave time for discussion. So where am I on time? No, I'm asking how many minutes?
You actually ahead of time, so you have
If I wanted to leave 7 or 8, 10 minutes?
you have half an hour actually in total.
Oh, okay. So I would like to leave at least 15 minutes for people to say what we should have said yesterday. Hopefully it will only take 15 minutes. So what happened? What happened was, first question was easy. Why not do PIPC and PANRG? And these are recommendations for protocol designers. If it's engineering, it's not research, so it's not PANRG. These might be BCPs. The ones for PILC were BCPs, and only the IETF stream publishes BCPs. But at minimum, we'd like review within the IETF before publishing them. So this one was easy. They got more complicated. We said that paths exist, but they may change. Actually explaining the idea of paths may be helpful on its own. We noodled about a bunch of things, but whether all parts of a path are equal in usefulness or equal in trustworthiness, but keep reading, whether you could make a distinction between access networks and core networks. We observed we do have trust relationships with some networks. Does that help? There are use cases like Wi-Fi plus satellite. Wi-Fi is the first hop, satellite is the second hop, with multiple interesting networks along the path. Are we talking about trusting a network or trusting the network, the worldwide internet? So that was interesting to think about. We recognized that there were first hop networks that are last hop networks for the other host, and asked if information sharing was possible, back to, I think, Brian's point about if we're talking about really stable, difficult to discover properties, then maybe they'll be stable long enough to share, and maybe they'll be useful enough to be worth sharing. I insert the advertisement for the, did I do that right? Yeah, the path properties draft, which defines a lot of our terminology, and which has been updated. Yes, exactly. Perfect. We talked about hints and not directives. We observed that we do use hints now, like ECN. And we did talk about, are there other hints that are possible? One idea that came up was, has anybody looked at IP TTL changes? So that basically, if your TTLs were coming in consistently at something like 30, and they start coming in at something like 2, is that likely to be correlated with anything else that's worth noting as a transport protocol? I promise that people like loops are thinking about delay as a hint. Again, this is something that doesn't involve a load of trust, but I mean, like, we thought that hints are likely to be less disastrous than directives, but we're not sure they're always harmless. Actually, we're pretty sure that's not true. So telling path hosts, here's the path info, you should do the right thing, seemed like a good thing for us to do. Can you peek and see how many more slides I got? Or no, you actually can't. So I had that one, and yeah. So I've got two more. I got 2 more slides, and Mr. Cool, Brian No Hat.
Brian Trammell, individual. Can you, given sort of like how the set of possible architectures that might interoperate with the current internet architecture are built, can you ever do anything other than this? Are directives, so there's either a type of hint that says, here are the properties of the path, maybe you could use this to do something better. And there's another one that is essentially a hint with a threat. Here are the properties of the path. If you do not assume this, then you're going to have a bad day because of these other properties of the path. That last thing is as close as you can get to a directive in architectures where you don't have integrated data control where, send me a Bitcoin or I won't route your packet sort of craziness. So, I mean, hence not directives. Are directives even possible? I would say no.
Cool. And like I say, I think that's definitely, like I say, remember, I'm giving you a 12-person rant, multiplexed onto Spencer. So we still have conversations to have, definitely. Yeah.
Igor, so it looks like these hints are exactly the things that try to ossify protocols. RFC 8558 says that you really should only use explicit signals that are made for purpose. And so things like, TTL is changing too much. This is really dangerous to consider it as any sort of a hint or a directive, of course.
So I think what you're talking about is possibly a tension in the room yesterday morning between things that would be interesting to research and things that might feed into a recommendation to the IETF. So I think if I understood what you just said, that's probably really relevant to what we might or might not tell the IETF. But researchers are curious, so.
I mean, curiosity is great, but if the curiosity is acted on, it may become dangerous.
I volunteer with teenagers. I agree with you 100%.
Eric Klein. I can tell you that certainly watching IPTTL changes between on a certain network behind walled gardens in Asia. 1.1.1.1 on port 53 and on port 853 had radically different IPTTLs. One was returning stuff around 48, and one was returning stuff up in like the high hundreds, just under 200. So it was a sign of interference, not necessarily a path characteristic, but still a worthy signal to have been able to raise.
Cool.
I had to find it out with TCP dump.
So we had an idea, and it's not a great idea. And next, thank you. I want to spend a few minutes on this one because I think it's really important for what we're able to think about. So we're a research group and we can think about anything, but that we can think about, what we can think about and do that in an effective way. Trust no one. Literally no one. Some application protocol designers don't want to trust anything. This is a direct quote from a person who I can't identify further because you would know exactly who that was. With any further description, saying, "Oh, you want me to trust signals from the network? You want me to give signals to the network and trust signals from the network? How about if I give you no source or destination addresses? Does that work for you?" Because that's really what he would like to do. Okay, so the important thing for us to remember in PANRG, my opinion, is that we're providing transport services to those protocol designers too. We have to figure out what we can do and what we can't do. And doing that in a research group is a whole lot less painful than doing it in some working groups that have tried to do that. Speaking as a former responsible area director. We're using TLS, which is inherently two-party for a lot of stuff. We've talked about how to make it 2.5 party or 3 party, and that has been pretty consistently the wrong answer in the IETF. So for us to think about trust, we need to be thinking about that really seriously. So back to the previous conversation about what can we do that might minimize to minimize trust requirements, because anything we can do that would minimize the trust requirements for a mechanism might be a big help in getting it deployed. Any thoughts on this one? I think I have. Yeah. Okay. And this is actually a continuation. The first thing on here is actually a continuation of the previous slide. So we're still in the previous slide. So please sit on the mic.
Eric Klein, I've been contemplating a kind of a hybrid network architecture. And in this scenario, I think when you talk about trust, you have to like, what do you trust? And the less you ask people to trust, the more useful and generic a signal can be,
Yeah,
right?
sure.
So I got down to the point where I was thinking, let me just, not to be prescriptive here, but just for my particular case, let me just cite local multicast at basically some kind of path characteristics have changed. You might begin reevaluating now. Hint for appliances, applications, and transport protocols to start doing some work. But like, yeah, the less you ask to trust, it definitely seems better to me. Because otherwise, you actually trust what? You have to give it increasingly specific information to trust. And that seems to be getting, that seems to me going down the path of high prescriptive kind of direction.
Thank you. So Tommy's making a break for it.
I can't take notes anymore. Tommy Polly Apple. So I just had another thought on kind of trust. And you had a point earlier about kind of like having the different parts of the path and knowing, are these equal in trust or how you relate their trust? So it got me thinking, so I actually wrote my comment in the notes so I don't have to type it after myself. So, you know, one of the things I think we've brought up in this room before are like provisioning and provisioning domains, telling you information about the path. This is one of the mechanisms to do that. And so what we've been having discussions as we're progressing that work and that document about, you know, what are the guarantees of what we're trusting, right? Because this does not make your path safe. It does not mean that you can really trust that the thing is truly a captive portal. It's truly giving you a Wi-Fi or cellular uplink. And one of the few pieces that we are able to somewhat confidently say we can trust is when like the information that is, you know, hopefully signed or encrypted somehow can match and essentially show that these elements of the path are associated or coordinating, right? So we don't know if they're good or bad or if we should trust them, but we can see that they are colluding or sharing properties, and that becomes a useful thing to know, right? So it means that I can essentially transitively build out my trust. Like if I have something that, all right, I'm on the local network, I don't know how much I can trust my router, but I do know that this other thing has clearly coordinated with my router because they know the same information. And so I can kind of build out these dependencies of, well, if I'm going to use this, I may as well use this other thing as a hint because it's related. So maybe we can talk about that type of trust building on top of this.
Thank you, Tommy. This got slammed out about 5 minutes before the plenary last night. So I got everything down that was at the meeting that I could understand in my notes, but this one probably belonged on the previous slide. So there was a talk at IRTF Open about hardening NTP. With a project called Kronos, and there was a talk on that Tuesday morning at IRTF Open, whenever IRTF Open was. I'm sorry? Tuesday. Oh, someday this week, which was not Friday. So basically the deal was, NTP works within a threat model. So let's say that somebody got really creative attacking you and had maybe a third of the possible NTP servers that you were sampling, so that they can really drag stuff around. So what could you do to prevent that from happening? And the quote was, you're looking for the talk on preventing time travel in NTP. There's actually 3 drafts in the NTP working group on the same topic. So there's way more detail than even in the IRTF talk and paper. But so basically the thing was, how do how big a spectrum can you sample from? And how sensitive do you have to be to accepting changes from the sample that you got back compared to your current time? So, the model that they had was basically if you sample pretty widely and, if you have somebody that's attacked, has, I think the numbers were like a quarter of the NTP servers that you might sample. And if you sample widely and if you compare pretty closely to your current thing, it would basically take about, and sample 3 times every 3 seconds, I think the numbers were. But the point was that it was like, it would take you, like a century or two to pull the clock forward 200 milliseconds. So basically somebody's taking a protocol that's pretty trusting of what they get back from untrusted endpoints and doing some exercises on it to make it more resistant to manipulation from an unauthorized participant in the protocol, or 30 of them. But I wanted to be sure and mention that. Like I say, it was a really good talk, and I talked with the person who was presenting last night for probably 30 minutes about it after that. So I wonder if there are models like that that are helpful for us. We do have various forms of what transport encryption means, or why transport encryption is harmful, or things like that. We have, there are various flavors of documents like that floating around. So for us to be seriously thinking about them and deciding stuff. The PILC working group, which was kind of my model for starting the whole conversation in the first place, they did analysis and then they worked on recommendations. They didn't publish the recommendations until most of the analysis was done and published. So that might be a model for PANRG going forward, because PANRG could certainly do the analysis, even if it couldn't write BCPs and request publication on them. Looking carefully at the chairs to see if that sounds like a stupid thing. I'm seeing one really cool head shaking side to side. Oh, yeah.
It's Nicolas Kuhn from CNES. About recommendations on congestion control. I don't know the outcome of the TCP/M session because it is happening right now, but Gori is going to present guidelines for congestion control. That was an old RFC, and he wants to maybe make an update on that. So he has a section on past characteristics, so maybe worth having feedback and exchanges on what is in this document.
Okay. Thank you. We did mention that we need to remember APIs because, like I say, as I said a minute earlier, Lars was encountering languages like Rust that hide ECN. Like he doesn't know how to find out whether ECN was set or not in his application. So for us to think about that. And hearing other footsteps, and I screwed up this acronym, it's APN6. But T's and PO. So here are the people that are trying to communicate between the transport and the network, and here are the people that are trying to communicate between the applications and the network, and here are the people that are trying to communicate within the network. And it would be a good time to have if I can use this word, a deep dive, basically saying who is all trying to fix the same problem, and who is actually working on different problems. Where are the overlaps? Where are the gaps? So it might be interesting to have that conversation sometime. So my last thing is, of course, that communication is almost always a good thing. So I got to my please discuss. I don't know that I need to be at the mic for the working group to talk about this, do I? Okay, cool. Well, I will sit down and let other people talk.
Other reflections on this? So I think we had some discussion during the presentation. I don't know if that was necessarily what you wanted. Do you have like particular questions you'd like to ask?
So, like I say, coming from my perspective, the question was, can we make recommendations to IETF transport protocol designers now? And the answer is no. So, no. So if people think that that's wrong, that would be an interesting conversation to have either here or on the list. But I didn't really have questions after that. I was just reporting the 12-person rant to PANRG, which seemed like it was the most immediately affected bunch of folks.
So that I especially like your last point on your last slide there, not to please discuss, but the communication is a good thing. To some extent, this room, I think personally, and I say this as the chair of the research group, trying to grow the research group, is a really good place to have those conversations, because it's sort of like, in addition to this research program, we're sort of the interest group for doing this sort of thing in an IETF adjacent space. As to whether a research group can give it advice to protocol designers in the IETF, absolutely, as long as that advice is not binding or meant to be binding, right? And that's an interesting question. Do you want the advice to be binding or not? And what is, yeah, I mean.
So actually, if you back up to the slide about, I think it's the immediate previous slide. If you do the analysis here, then that's telling people, but it's here, but it's just telling people what you're doing. If you are making recommendations, that's strongly encouraging people to do whatever. And that, like I say, and I think I put this early on, this at least needs to be in the IETF to get IETF review, because IRTF documents are not supposed to get extensive review in the IETF unless you ask the working group yourself. And if you want to publish it as a BCP so that it would actually be binding, and that the ISG would act like they'd never seen it before, then it really, that's got to be in the IETF.
That seems perfectly reasonable. John?
John Border. I guess I think the question is, does PANRG want to take on the analysis task? I think that's the question.
Yeah. This seems as good a room as any in which to undertake that analysis task. I think that, so if I'm looking around, today, and we have a very unfortunate conflict with TCPM, so we actually discussed this, and the outcome of that discussion was, well, we kind of screwed up and conflicted with everything in routing for our first three meetings, so why not see what happens when we conflict with something in transport for the next meeting? And so I would not, as chair, want to look around the room and say, well, we have a pretty good filter on this room of, we have the transport people who care about this question in here and the transport people who don't care about questions in this space out of here, because anyone who cares about TCP is also not here. So, oops. So that, I would want to have that discussion out on the list, Spencer, as to whether or not we want to take on this analysis question. Oh, and Aaron is leaving the room to go to TCPM because he's just realized that TCPM is right now. Bye, Aaron.
Love you, man. Love you.
So that, I don't think we can answer that question in this room right now as to whether or not this is the right room, because this is not the right room. I do, as chair, this seems perfectly within the charter of the research group, and also within sort of the, why are we here, right? So this communication is a good thing. And I think this is the right venue to do it, because like other transport area working groups are not the right venue to do this kind of analysis. So it's do it here or run a BOF. And that's not a threat.
Yeah. And I appreciate that, and I'm just noticing that you are doing the analysis on scheduling conflicts now, and that I'm sure you'll make recommendations after you've done the analysis. Thank you for demonstrating that this is a path forward for something.
My analysis is that the IETF should be a 7-week-long single-track meeting.
Yeah! Tommy Polly, Apple. So this is a comment not particularly on this document, but on this broader discussion of, the right people in the room and encouraging communication, because I agree that's a very good point to end on here. I mean, it does seem to be a little bit of a theme here that we've had small rooms, partly because of conflicts. Are there ways, to the chairs, that we can start building up more of an interaction model similar to what we see in some other research groups like ICCRG, which is like clearly a place where you come and present anytime I'm doing a new change in congestion control that's affecting what I'm deploying quick in TCP, it's presented there. Or even when we look at MapRG, I think MapRG has done a great job of getting, like, whenever there's new work on quick, whenever there's work on TLS, IPv6, it does get shared there. So can we, kind of solicit, if we're trying to do this work that could give advice to IETF, before we do that, can we get more solicited talks from people who are working on their individual protocols? And I think that will also help drag along more of the crowds from those rooms like Quick and others.
Yes, I mean, like, yeah, TLDR, yes, obviously. As to, I would actually have to go back and read the research group charter because it's been a while since I've done it. I think we might need to add a sentence or two there. I don't think that that's particularly hard. I think we would also need to check with the transport area directors as to whether or not they thought that was a turf grab. But they're over in TCPM right now, so we can't ask them that. I know where to find them though, so that'll be, we'll definitely bring that up. My concern as chair is how to scope the question, right? Because it's like scoping it around things that are definitely in scope for this research group. I mean, it's got path and aware and networking in the name. Networking is pretty easy to deal with, but like, what does path aware mean? And that gets back to sort of like the feedback that Spencer got yesterday that, hey, having just a document somewhere where we can talk about what we mean when we say path would be useful, because we have a very particular idea of what we mean when we say path in the definition of path for path aware networking, which may or may not be the definition of path that we want when we're talking about these sorts of things that came out of the Son of Built discussion yesterday. So I think that probably Spencer, you should sit down with the two of us on the transport ADs, and we should figure out what that looks like in terms of like, and maybe call in and figure out what that looks like in terms of charter changes for the research group and how we want to scope that. So it's not just like, hey, if I really don't want PANRG to be, if you have a transport idea that you can't get traction for in TSV area, come to PANRG. That I want to avoid that, right? So I think we need to do this a little carefully, but like, I think it's the right thing to do. And I think that, like I said, this is the right room to have this discussion, and we have the right set of people. We just need to write the right description for the right set of people so that it works out. Thank you. So I think we're next.
Teresa?
Tommy, did you get all of that down? Because I'm kind of tired. I'm not going to remember any of it.
Yeah.
Thank you.
Okay. Hi. So me and Cyril got a draft that basically aims to answer the first question of Brian's questions draft, which is about path properties. So what path properties exist and how do we talk about them? And the major feedback that we got so far was about terminology. And therefore we revised our terminology to make it more rigorous and to make it clearer. So I'm going to present what we have now. We are defining nodes as entities that can be physical or virtual and that are processing packets. And nodes might be either hosts or routers, which we define as either the host is explicitly addressed, for example, as an IP address. So of course, addressing can be on different layers, and we talk a little bit about layers in the definitions too. But for the purpose of our path, we need like hosts and routers, and the hosts in this example are the ones at the very end of the path, and the nodes are in the middle, the routers are in the middle, and both the host and the router are nodes. Between nodes, there are links that are connecting those nodes and that enable them to exchange packets. Of course, a link can be between more than two nodes because we have broadcast medium. And a link can also be virtual, doesn't have to be a physical link. So for example, if you have two virtual machines that are running on the same physical machine, there might be a sort of virtual link between those virtual machines. Right, so we have nodes and we have links. Now, if we string those together, if we have a sequence of adjacent path elements, because both a node and a link are a path element. So if we have a sequence of those path elements, then we might get a subpath or a path. And the subpath is just between two nodes, either hosts or routers, and it starts and ends with a node. And of course, the nodes and links have to sort of be adjacent and also alternate. And the path starts and ends with a host. So then there's packets exchanged, or there can be packets exchanged between those entities, those nodes. And we are defining a flow as either one or multiple packets which are traversing the same subpath or path. So it's not just the classic definition of the 5-tuple IP addresses and ports and transport protocol, but a flow in our definition that we use in the current draft is it can also be all the packets that are traversing the same link between two particular nodes, for example, because we want to define a property as either a trait of a path element or a sequence of path elements. And this trait might be related to a certain flow, such as a packet or multiple packets that are traversing this path or subpath or the sequence of path elements. And so we get a path elements, we have a flow, or maybe we don't have a flow because it's just a trait of the path elements unrelated to any particular data transmission. And then there's a name and a value for the property. So this is the current definition of the path property. Questions?
Very quick clarification question. Is the sequence of path elements adjacent or not? i.e., is a sequence of path elements the same as a subpath? Or is this a collection of them could share similar properties?
Yeah, this was a question that me and my co-author discussed. And I first had a subpath in there. And then he said, oh, but maybe you have like just all the routers that are sort of behind each other on the path. But then there's links between them, but maybe you don't mean the links, but just the routers. And that's why it's a sequence.
So another clarifying question: do path links and nodes to alternate?
Yes, they have to alternate. That's in the definition. And you might have a virtual link between two nodes if there's no physical link. Or even if it's two processors on the same machine, you could define like the sort of the pipe or whatever virtual interface there as a virtual link. But we actually wanted to keep the definition so rigorous because otherwise you might get nonsensical paths.
I was thinking the other way around, whether you can chain multiple links that have no routers between each other, which really resembles network architectures. If you're looking at physical architectures and Ethernet with something like switches and bridges and
Wait. A node doesn't have to be on layer 3. It might be a layer 1 device or a layer 2 device, right? So there's nodes that are sort of hidden. If you look at the path on layer 3, there might be a switch somewhere in there and you don't really look at the switch, but yeah, so we have this layering thing in the draft. And we were also discussing this. For example, if you have some fiber optics and then there's a passive splitter between them, then it's not like, is this a node? Because it doesn't do anything. And you have one fiber, you have a set of other fibers. But then we actually said, okay, maybe it's still a node. It's passive, but yeah. So there's kind of always nodes between two links.
Eric Klein, I assume that this is unidirectional.
What is unidirectional?
A flow, sharing the same sort of set of paths in one direction.
Yeah.
There may be return path
You
traffic
might
that's asymmetric.
also just talk about two packets, one packet that is sent in one direction and the other packet that is sent in the other direction as a response. This can also be a flow. Then you can have a bidirectional flow.
Right, but the pathing might be asymmetric.
Yeah, the path might not be symmetric, of course.
Okay, so a flow then is about the packets, not necessarily about the paths that they take?
Yes.
Yeah.
No, I'm making a suggestion as an individual. Brian Drem. A flow is an entity to which the traits of a sequence of path elements may be applied in the functional sense. Okay. A flow is an entity made of packets to which the traits of a path or set of subpaths may be applied in a functional sense.
Right.
I have a flow. It's got packets. The packets are formless and void. I send them down a path. That path applies its traits to those to the packets in that flow as they go past.
Yeah, I'm sure we can find some wording for this.
That trades the problem that you have right now for a different problem, but I think it's a better one.
Hi, Aliyah Atlas. So 2 questions. One is, you're assuming the endpoint is always a host. I'm wondering if you're deliberately leaving out overlays because they're kind of everywhere. And so even if it's a subsection that's indicating this is in, this is out, I mean, one of the things that's very interesting potentially about PANRG is being able to think about it and improve benefits for overlay networks. And if you want to talk about improving adoption, if networks need to use functionality to get the behavior they want for their overlays, then you are facilitating the possibility for end-to-end. So I'd encourage thinking about that.
Yeah, we have thought about overlays too, but okay, in our definition, an overlay would be a router, not a host, potentially, but then we have a subpath between different overlays. And why is that a problem? I mean, you can still define a property for a subpath. Or maybe we need like a hierarchy of how involved is the router in the path or something, but I don't know.
Yeah, so there's different pieces. When you get traffic coming in as a flow into an overlay, you might be taking that and putting it into a specific microflow, which is different from the native flow that it came in. The router may use different properties to head out the outgoing link, like it might use the original microflow as opposed to the overlay microflow. You may have less flexibility in terms of what you can do. I mean, you're probably not running, the equivalent of a TCP stack for each of your connections. So I think it does have a number of implications. And I guess since I'm up here, the other question is, and we keep talk about paths as if they're static. And they're not, because you have hashing and you have, and so I think having some way of discussing the time relevance of the path definition might be interesting, and also sort of the liveness of the path, right? Because that's one of the challenges is you send traffic down the network and God knows where it's going for your layer 2 lag, and who knows where it's ECMPing. And if you can't keep traffic going down the same path and know it's live, that's pretty hard.
Okay, thank you for your comments. I think they're very useful. So to the first comment, I think this goes back to our definition of node and host, of host and router, sorry, because like it's addressed to a host. Okay, on what layer? I mean, I said that before. So yeah, I guess we have to think about encapsulation a little bit more. And the other part was about, oh yeah, about the path. So right now the path is defined as, well, it's there and it's, in theory, it's possible to send a packet over that. And then the packet gets sent and yeah, it will take one of the paths. So we're defining sort of all the paths. And then we have a property maybe related to this path that could be used by a packet, or we define a property that's related to a specific packet that is going over a specific path.
Yeah, I just like to cut the line because we're slightly over time, so quick
already.
So kind of you, but still.
So what I was suggesting is your path is time dependent.
Well, no, it always exists, but then the property might be time dependent because it depends on a specific packet at a specific time.
No, the arrangement of links can change.
Yeah.
Completely.
Oh,
It's time dependent. You can't assume it's static.
Okay. Then it's time dependent, yeah.
Stuttgart, I have a question on terminology, slide 3. What do we call a flow when it doesn't satisfy that definition of a flow because the packets do not traverse the same subpath or path? And if that's answered on a later slide, I'll just sit down.
Yeah, perhaps we have to update the definition in line with what Brian said before, because I actually just want a set of packets that I can apply a property to and that are in some way not completely unrelated.
So I had a question and then I have two observations. The question actually I think you've answered implicitly. You're not making any particular constraint on the layer at which a link exists, correct? Because you referred to links that might be virtual, links that are pipes, which is layer -4. The observation number one is that Spencer had an ask to create a document which defined a path for the rest of the transport area, and it looks like from this, if you take your document and apply to it the set of comments that you have received, the first half of your document becomes that document. I'm not sure you necessarily want to be the person to edit that because there's a fair amount of work involved, because this is now, you've noticed that you're having like a whole bunch of questions and comments on your terminology slide number 3. That has words on it like flow, which the IETF has never been able to come up with a single coherent definition of. The routing area has a coherent definition, and the operations area has a coherent definition that's based on 5101 and 7011. But you know, when I use IPFix flows and I talk to people who run routers, and they're like, "Oh, that's a microflow." And now we have a different definition of flow, which is like the integral of the application of the function of the path elements traits dt, according to, right? Yeah. So, which is a different definition of a flow, which might actually be the superset definition of all of the definitions of flows in the IETF. So all of this stuff is really hard, right? Like, so you are trying to define path properties, which is a really, really easy definition. Like, I like this definition as long as you have a definition of sequence of path elements and flow, right? Like your property definition depends on these other definitions, which we have never been able to agree on. Your challenge, should you choose to accept it, this document will self-destruct in 15 minutes. Your challenge, should you choose to accept it, is basically run this all the way to ground and then talk to Spencer about, run this all the way to ground. Follow this effort to its logical conclusion, which is where you have an actual definition for all of the traits down to, or all of the terms down to the root. And then talk to Spencer about whether or not you've just finished the document that he wants to write. That was all as individual, by the way.
Yeah, not very good.
Yes, I cut the line here. We run out of time.
Okay, yeah, Richard Yan Premier. And so I think this is wonderful when you talk about this essentially path definition. And for example, given that it's the IR research group, and oftentimes, I guess, fundamentally, when I first see this definition of a path, very likely it comes from graph theory, right? And But somehow a lot of debate in graph theory oftentimes is, do I define by path or do I define by flow? Not here the flow in the context of graph theory. Basically, oftentimes is one major problem we formulate a lot of problems using paths is you have a problem of enumerating exponential number of paths. For example, look one example. Suppose here you have 1, 2, 3, 4, 5 nodes, and imagine between any two nodes you don't have a single link, you have two links. So therefore, suppose you have n nodes, you're going to have a total of 2 to the n number of paths. That's exponential. And oftentimes, really solve this problem oftentimes. For example, using ECNP, I'm not going to enumerate every single path because exponential. And then I would use, for example, equal split. Use a hash, whatever eventually is, I don't really enumerate all the exponential number of paths, and therefore I really make my problem to be essentially scalable, making my measurement to be scalable, making my information discovery to be scalable, and so on. So would that really be in scope? For example, for that case, how do you envision to model that particular case? ECMP and, for example, exponential number of paths using hashes. So therefore, you don't enumerate paths, and essentially you make it implicit. Maybe that's the way you can go.
Okay, if you could be quick comment, it would be great.
It will be a very quick comment. It's Nicolas Kuhn again, and I think it was mentioned in the draft, links are considered bidirectional, but in our satellite use case, we have huge asymmetry between what we receive and what we send. There are huge different characteristics. So you may want either to say that links are unidirectional and there may be two links between two nodes, or something, or clear that is bidirectional.
Sure. Okay. All right, thank you for all the feedback. So I guess the terms are not yet clear and consistent enough, and we'll go back and revise it.
Let me actually just throw something out as chair. Despite the fact that we need work on the definitions, do we want to adopt this document with the idea that it's essentially on track to become the document that we want, or do we want to basically send it back and say keep going? I mean, I think that get it completely right before we adopt it. This is a thing that I actually do in my working group, but this is not a working group, right? I mean, do we as a research group believe that we need this draft or would like to advance this draft forward with the idea of publishing it? And if so, do we think that it's on track enough that we would want to do a call for adoption? Spencer.
Spencer Dawkins, I would like to see you do a call for adoption. I think one of the things that would make it easier for Teresa to move forward on the document is to have more people looking at it, which, when the thing becomes a research group document, that becomes our collective responsibility. I think, one problem you may be dealing with is that you know what you mean, and having more people look at it that don't know what you mean would be a lot of help. Adrian Farrell has the bring me a rock problem, which is basically you say, bring me a rock, and I bring you a rock, and you say, that's not the right rock, bring me another rock. And I think that adopting it would get you out of the bring me a rock theory and basically say, this is the kind of rock that we've got, this is the kind of rock we're looking for, and it would make it easier for you to bring the right rock back next time.
Spencer, before you sit down, was my characterization as an individual of the first half of this draft might be the draft that you want? Does that, with respect to the defining what a path is for these, does that resonate, or am I off base?
I think that's true, and I think also someday, and soon as the time, but soon as a day, but someday I think we're going to be happier that we've got definitions that we can show people rather than having them say, I kind of know at a hand-waving level what your research results mean, and now I'm going to go off and engineer based on that in the IETF.
Yes, we're 10 minutes late, so quick, please.
Eric Kinnear, Apple. So I would echo much of what Spencer was saying in the sense that our ability to communicate with other people is going to be much enhanced by having these things defined. And I think we've seen that if you show us something, we can think about it and talk about it, and having it be a working group document would help that a lot. And I think it fits a natural place in what we're trying to do.
This is a research group, I guess.
Sorry, pardon me. You're right. The question from there becomes, as we look at the other places, other areas have defined similar terms. I think the challenge for us is going to be, how do we make sure we can communicate across those without going too far from there? But that's only aided by making it a group document.
I know we will hear from Al, who is redefining the term node in IPPM.
Yeah, hi, Al Morton. So if you take the IPPM root metrics draft and the terminology that we're about to change to, it looks a lot like what's on your slide, Teresa.
Okay.
And so I'm that's the engineering side of our happy week here. I guess I'm wondering what value the draft on terminology here in research brings. And there may be a broader perspective, and I'd encourage you to emphasize that as you go forward. We're kind of bound in the old world of tuples and flows and stuff like that. That's what our flow definition looks like. Maybe there's something more that you can bring to the table there. So I don't discourage this. I don't discourage the research at all. But I just bring up that we're basically at the same level, plus or minus, I think, what we call a flow. Thanks.
So we're running late enough that I don't want to do the whole helm ceremony for this. We will follow up on the list with a call for adoption for this one, but assuming that goes in a couple of weeks, we'll know. So thank you very much.
I can probably do this in 15 minutes, so that's okay. Hi, I'm new here. My name is Torben Krüger. It's my first IETF, and so my contributions might be maybe trivial to many people here. And also during the past few days, I had a lot of fun, and I really enjoyed the discussion culture here, but it also caused me to really completely rework this set of slides and get a different focus. That's the first disclaimer. The second disclaimer is that I'm sort of involved with a Scion project that Brian was also involved in. And this might color my perception of what path-aware networking might look. And so I might have some implicit assumptions that might not be generally applicable. But yeah, and just let me continue. I had looked at the questions draft, and in particular the questions 2.7 and 2.8, which I would like to paraphrase. So question 2.7 is, how can a path-aware network reconcile the apparent conflicts of intent between endpoints and the network? Is that a fair summary of that paragraph, would you say? Okay. And the question 2.8, how it would be in the interest of the network operators to surrender path selection authority to the endpoints. So when we are giving the endpoints the opportunity to decide what paths they would like to take, then the networks can then go ahead and not respect this decision. At least this is how Scion is designed, where actually the networks can't really change anything, but might not be that clear cut in general. So I asked myself, don't these two questions all relate to the question of how path selection in particular is to be implemented on the endpoints? What kind of behavior do the endpoints actually, should they use right now it's sort of, to my mind, it's kind of glossed over, and the endpoints will do the right thing, or the thing that is in their interest using this information that they get. I found in Teresa's draft, I found the following requirement that says an endpoint's path selection algorithm should aim to not perform worse than the default case. Okay, that you might construe this as a sort of a requirement for the endpoint. As a corollary, I would also say that path selection should not be to the detriment of the network in the default case. And I would sort of, I hope everyone knows this guy, Immanuel Kant, who said, act only according to that maxim whereby you can at the same time will that it should become a universal law. That was kind of mouthful, but maybe we should, the path selection behavior still needs to work when a significant number of endpoints use the exact same behavior. And thereby it must account for the fact that it might be in ubiquitous use and might thereby have effects on the network itself. So for instance, a very simple example would be flash crowds, where the latest OS update goes live and millions of bandwidth maximizing endpoints simultaneously pile onto paths that promise the best throughput. That obviously causes changes in those paths, right? In the properties, in the dynamic properties of those paths. Or when you have World Cup finals and millions of people want to not lag behind their next door neighbors in being able to cheer for the next goal. And it's sort of, to me, it's clear that naive strategies fall on their faces, right? They are likely to lead to wild oscillations. I've built a test bed where I had a toy path-aware network where I could actually demonstrate that using these naive approaches, I could show that actually you get these problems with oscillations where when everyone in the network is using the same strategy to act on those path properties, the changes that they cause on the paths lead to feedback loops that are kind of hard to dampen, actually. So even when you introduce a dampening factor and say, okay, I only switch away with a very low probability when I find out that there's that the other path looks better, you still get these longer oscillations, but they are still oscillations. And when you go much further and really tune down the probability of reacting to a better path becoming available, it might not be that simple to simply specify that switching away to a better path is always beneficial. So maybe there should be guidelines for path selection behaviors. And I would like to pose the question to the audience. If maybe we need to, is this might be become part of the questions draft, that the actual behavior for path selection should not be out of scope for us. Or, I mean, the other question that we might have to ask when we say, okay, we don't want to specify this, we don't want to constrain path selection itself, we want people to be able to do what they want. But then we have to ask, should it be okay for networks to misrepresent the path properties depending on who's asking? So this is in a world where the networks are communicating the path properties and I don't measure them or anyway. So I can query the network for path properties. But when I'm not being smart with these properties, then it's in the interest of the networks to maybe start lying about them. So, and I would like to pose this question. Should path properties, should there be a universal agreement that path properties can be trusted, or is this something that we might need to give up in case the endpoints are being stupid? Thank you.
Yeah, we have like 6 minutes.
Teresa Enghardt, thank you for this talk and for your perspective. I'm really interested in path selection strategies or behavior, as you call it. And I would be interested in details of your setup, but I fear we don't have time for that. So I just wanted to say this is probably related to question 2.3 as well. How can an endpoint select paths to use in a way that can be trusted by both the network and the endpoint, is what I wrote down for question 2.3. There might be an addition to question 2.3 in the questions draft in there, and there might be potential thinking about answers.
Yeah. I didn't want to disturb the discussion earlier when we were talking about the questions draft because I wasn't quite sure if this was actually a valid contribution, and also I had prepared this talk.
Yeah, so I'm cutting the line of the people who are standing there.
Okay. Hi, this is Sabine. So great, thanks for this presentation and bringing this issue. Actually, yeah, there is one citation, or not so historical, that we can do is that only in car traffic, a variation of 5% generates a traffic jam. And the issue you bring and the consequences are really similar to, for example, if we change the routing path. So yes, definitely any functionality allowing to change a path from the endpoints should be moderated. There should be a moderation function that, with all those hysteresis, thresholding and stuff like that, definitely, yes.
Hi, Brian Trammell, individual. Thank you very much for giving me a chance to cite Kant in an internet draft. I think I will actually add this categorical imperative thing to one of the questions. I think the 2.3 is probably the correct one. One question that I would have for you, I think this is a valid and valuable contribution. Thank you very much for bringing it. I'm not sure what the ask is. I mean, do you want to turn this into a draft and run it here? I mean, that's not a question for you right now. Think about it. I think it would certainly be useful. One question that I would have back for you with respect to all of the other points that you raised is, to what extent are sort of these competing control loop problems different in a path-aware network compared to a current network where this information comes from measurement, right? And that's actually, I think, the question that we need to distill your questions down into, and that's a question that we need to address, because I think a lot of the things that you're raising of like naive strategies with bad feedback are questions that we've run into in engineering in the transport area before, right? Raising the question of what does making this path aware add new to that, I think, is one we don't have an answer for, and one that we should dig into. And I look forward to your future contributions on that within this research group. But so the point is, the framing here is like, hey, this is a new thing. It really isn't, and it looks a lot like, so the graphs that you showed, if you like take off the X and Y label axes and the labels at the top, I've seen those graphs before in ICCRG. For example, right? Like, so where you get these things that are doing naive things with bad feedback, then they do this. It's exactly the same thing. So I think I would encourage you to dig a little bit more into what the specialness of path-aware networking is there. Thank you, Tom.
Thanks.
Tommy Pauly, Apple. Could you go back to the slides? So, right, or just to the question. So I think the second question, while it's interesting, I'm not ready for that one yet, because actually going back to the first question, kind of what we're talking about here, like, should we be doing this? I think that's still something that's very interesting, and I totally agree with what Brian said. I came up here to say, like, oh, this looks very similar to the graphs we would see in ICCRG. And like this could be, like one of the ways in the possible paths that are changing for this group. A way that the group evolves is to be a place where we can do the analysis for the equivalent work that is done in ICCRG for congestion control over a single path, for how it plays out when we start becoming multipath and doing path selection on these, and kind of that extra dimension of that. So I think figuring out a way to make this more rigorous, and maybe to the point of getting advice and stuff from other groups, when we have other groups that are doing explicit path selection, let's say MPTCP doing work, especially if we start doing PVD stuff and multiple uplinks on the same local network, where we are starting to do more explicit path selection, have that work be demonstrated here, and also do more experiments in conjunction with that.
Philip Teasel, I just wanted to give you an answer to the next question. And I would say the question is definitely no.
Thank you.
If you want, if you think you need to lie about these kind of properties, the question is this the right metric you're working on? Or should you have some kind of derived metric that you can be honest about? And I think this is one of the core questions we have. What are the right metrics? And if the right metrics from an observation or measurement point of view lead to oscillation in the control loop, is it the right metric to decide upon, or do we need some derived metric or something completely different to act upon?
Yeah.
And therefore not lying, please, but being honest and finding out whether that's useful.
Yeah, so this was intended as an obviously rhetorical question where the answer is no.
Yeah.
Yeah.
Thank you. John?
Yes.
Okay, my name's John Border. I'm actually going to go through the early slides about how the test is set up quick, because I want to get to the path aware question towards the end of my presentation and spend time. I reread the questions document last night, which raised the question in my mind whether this fits. And also some comments about RTT raised the question in my mind about whether this fits. So basically, what we're trying to do is, we have split TCP PEP. We can't do that anymore with Quick. So we need to need Quick to perform well without this solution. So right now we were doing some tests to see, well, what's the disparity? What can we do? How fast can PEP go versus what does Quick do right now? So I'm not going to really go over this slide. This is just a test setup we have. It's in the slides. We have two setups. One is going through our equipment. One is just direct. The key thing is we have the 600 millisecond delay in there. So we're looking at a long delay test in large files. So, we did 1.1 HB2 with TCP spoofed, and then of course Quick, and then we also did without TCP spoofed. And we have a 1 gig connection to the internet. So we're trying to test high-end stuff. How fast can we go, not with real plans in place? And that's one of the reasons we're using a delay box. We have our own network, but if we did, we would be limited to planned rates, and we're not trying to do that right now. And then we also were interested in packet loss rates. Unfortunately, we're not really done with this testing, so we don't have very much data on the packet loss rates. But I wanted to present it because I really came here to talk about the path awareness part of the question. So here's some preliminary results. So with TCP spoofing state of the art, we're way over 200 megabits. Okay, we could do that pretty easily. We did the 1.1 and 2.0 because we discovered that 2.0 has some flow control inside of it. So we actually did that first and wonder why we couldn't get our 200 megabits. And so that's why we have results for both. When you run direct, you can see when there is no PEP there, those are the speeds you get with unspoofed TCP with 600 millisecond delay. And we did get the 1% packet loss, and you can see what the impact of that is over 600 millisecond delay in terms of packet loss recovery. So this is just an example to talk about the part of it. So what we are interested in is we want quick over satellite to be just as fast as we can spoof things today. You need a very large window. That's part of getting to the high speed. But you also need some kind of optimized packet loss recovery. So an FEC solution or something, some kind of local thing. You know, but the problem is, if you tune quick for those properties, in my opinion, they might not be good defaults for the end post to use all the time, which is where the path awareness part comes in. And then, you know, a loops-like solution can solve parts of this problem if it goes somewhere, but it doesn't solve the end-to-end problem. So this ties into what I was rereading the draft and the talk about RTT. What I'm really trying to do with what I'm saying here is I'd like to know before I even did my first connection that I'm in this environment and be aware and bring up so I could come up and be great performance from the start. One option is I could learn and remember, and certainly that's another path that I think has to be explored. But that doesn't, you know, the learning and remember thing isn't really fit in with, I think, the general questions of path awareness as I understand them now. I still think it's important work, but it's not clear to me how well that fits in here. There was a section on the early questions about being aware of this kind of stuff, but so it's not really clear to me, but where that is at. The only other thing is, you know, we're collaborating with other people on this testing. We really would like to find somebody who has a high-speed connection to a quick-enabled server on the internet so that we can have better control tests with the congestion control part of it. So if anybody's interested in helping us do some of these tests, you know, please come and contact me. So I went kind of fast because I wanted to also leave time for Nicholas to have more time. He's got more details than I do. But if anybody has any questions?
Theresa Enghardt, isn't that exactly what loops is for? The slide before said you can't use loops because something end-to-end, and I'm wondering, why do you need end-to-end? Also in the loops BOF, they said, oh, this is not related to PANRG because PANRG implies that the endpoint collaborates. So yeah, why do you need endpoint collaboration at this point?
Well, this picture can show me the link between the Hughes terminal at the top and that other guy is generally going to be Wi-Fi. Yeah. Well, loops doesn't go to the end host. So I have no way to recover that link, and that's actually where most of my packet loss is these days. And that's what the PEP is doing for me, is it's giving me that local recovery. When I throw quick into the path, it's not there anymore. I have to do everything end to end. So loops can help me in the middle, although I actually have proprietary solutions there, but I can't do that. That last hop link is the one why that's not enough by itself.
I think they were also open to build something that would work with a component on the host, but it's just the same component as could be deployed in the network. But yeah. Yeah,
I talked to them about that, and it's sort of a later phase. But, you know, it's definitely, I'm looking at the whole toolbox, and so that's definitely on my radar. I'm also looking at things we can do inside a quick and be, you know, at least the learning part of it and figure out you're there and then do something. But I still have that, the packet loss thing is the one that concerns me the most because of that end-to-end time it takes to recover from packet loss.
Hi, Colin Perkins as an individual. I mean, I kind of wanted to echo what Theresa just said. You know, clearly it would be better if Quick could solve this problem without needing things like loops, but certainly from talking to the loops people, it does seem that they're open to considering this use case.
Eric Klein, I wanted to ask more about the difference between HTTP 1.1 and 2.0, because whatever could be learned there might be applicable for how it gets solved in Quick as well. You were saying HTTP 2 has built-in flow control?
Well, I should say, well, it has the capability. We know for a fact that it was actually, Chrome had some limit of around 30 megabits that it was enforcing over the link. CJ's coming up, he might know a little more details. Get on the microphone.
CJ, Chijun Su from Hughes. HTTP2 you have a string level and connection level max receive window size. For Chrome, it is, I think you have for HD2, you have string 0, control string, and the other string. For the data string, Chrome current is a 6 megabyte. Firefox is 12 megabyte. That's what it is right now, the last time I looked at it.
Right.
So that divided by your RTP is a max. So it's theoretically it's like 80 megabit per second, but in practice you only get 40.
So it's not noticing any of the changes in TCP. I'm assuming this PEP is like CCSDS 714 kind of satellite accelerator type thing.
Well, I don't really know what you're talking about. So
okay,
it's basically a split TCP. The 1.1 was faster because we had multiple connections going high speed. That's really the thing. I mean, we have a proprietary solution. You know.
But I mean, so there's lots of ways to mess with the TCP stuff that's in the clear, right? So
Yeah.
I guess the HTTP2 stuff is not being noticed because it's inside an encrypted part and can't get fixed, right? That's
right.
This is an application level bottleneck.
Yeah.
And then underneath you have a quick layer, another receive window there. And then you have a linear socket.
In the microphone, please. Please use the microphone.
I think it's a strong argument that there needs to be path-aware signaling all the way up to the application. Seems like a good argument for that. So I thank you very much for this.
Thank you. I will note that because of our unfortunate conflict, that most of the people who would be able to answer your question about getting you access to quick endpoints are probably not here. So I would take that to the maybe the quick and the TSV area lists as well as the PANRG. Well, or you can also just ask on the PANRG list because the same people are on the list. They're just not here because of TCPM. So
right.
Just because of the conflict, you're not going to get good answers from this room because this is the wrong room today.
Yeah.
Yeah.
Yeah. I mean, Google has a.
But Eric's going to set you up, right?
Unfortunately, not entirely. So Eric Kinnear, Apple. So we have at least one quick implementation, and we have a CDN, which has a pretty big honking pipe to the rest of the world. So like that part's nice. But we would need to go talk to those people and see if we are allowed to do that.
Okay,
Lucas, please take
that sounds
to the
good.
list. I think you were going to help him out, but we gotta move on. Sorry.
Okay.
So, hello everyone. I know there's cookie outside this door, so I will be fast so that we all have some. This talk I'm doing now, I've conjoint work with Emil, John, and Gori. Basically, I'm presented it here is how we do with trying to provide best current practice on making quick to work well on satellite links. We know we won't be able to have parameterizations that will work for all Google CDNs, but I think that if we have CDNs in the satellite network, we want to provide a document to explain what are the parameters that are relevant for our use case. And if I present it here in PANRG, is to speak more about the insequent paths and that have very different characteristics. I don't know who is aware of that, but there have been previous talks and evaluations on how we have some performance issues with quick on satellite accesses. So this has been presented in MAPRG, and you have the links to the papers in the slides. Basically, so first, satellite links. We all have these trendy information about Elon Musk trying to send thousands of satellites, but today these high broadband LEO constellations are not really operating. Today, what we see, what we use today for internet access is mostly geo-based satellites. We have large propagation delay against which we can't do much, and we have a high loss rate when you are moving and there's a tree or when you are behind the Wi-Fi. But there's a point I want to make here. We have, unless you are in India and it rains a lot, we don't have losses on the satellite link. Losses comes after, from the satellite terminal to the end user. So that is why I'm here. We have, and also a point I wanted to make on asymmetry I made earlier on. Our links are very asymmetric, both in terms of capacity, on the jitter on the link. So we have these strange things. And if you are interested, I had a look at these old RFC from the PIPS working group, and most of the descriptions on satellite links you can find there is still relevant. So if you want more info on satellite links, here you have. So we'll go quickly on that. Satellite systems is a point-to-point link, or mostly used for TV broadcast as well. And the problem is we see a lot of trend in the market in doing backhaul, and so we have lots of different IP networks which are backhauled with satellite accesses. So the satellite IP network is only one part of the end-to-end paths. And so the problem is we have this long delay link. We don't have losses, we have a long delay, but then we have to interconnect it with networks which have very different characteristics. And I think this is why this use case is interesting for this group, because this is somehow a corner case for the internet access. But for our users, this is very important. So we have been thinking on what we can do to improve QUIC for SATCOM. That is something we have been starting to think of. We didn't make any publicity for that because we wait for QUIC V1 and proper QUIC implementations to make clear best current practices. We are not there yet. So just somehow brainstorming ideas we have here at the moment. And I will show you some results on how we can actually tune parameters on what we have done at the moment. So I liked the point on discussions being, we are open for discussion. If you want to discuss with us, we are open. We have GitHub issues, everything. So if you want to join the party, please welcome. We have things flying in the sky that are very funny to play with. First thing we always think of is initial window. So we have we have been using QUIC Go implementation, an old version. I don't have the number in my head at the moment. And so basically, we have the default parameterization, and we have changed lots of things, and mostly the maximum congestion window and also the initial congestion window. So the first point here is to speak about the initial congestion window, and we have done some tests. So these are the traffic patterns. I don't have time to go deep into that, but we have short files, medium files, large ones, and we play with mix of them. The main point I want to make is we have the RTT of 600 milliseconds on the left, and if you look at the results on here, basically, when you have large files, we have lots of, by adapting and tuning the QUIC stack, we have lots of gains. And also what is funny to see that this parameterization does not, we do not have any impact on the low RTT case. So we think, trying to think of our poor use case when doing evaluations in QUIC may be relevant for everyone. And indeed, we can see that increasing the initial congestion window helps in reducing the downloading time of an object. But people don't like high initial congestion window because they say we are sending bursts of packets in the network, and that is bad. We agree with that. We say that you can increase the initial congestion window if you pace your packets out. So but we also wanted to check whether all the gains we had was from the initial congestion window, but also from all these parameters. And what we have seen is basically we have slightly less improvements, but still we gain a lot by adapting lots of parameters and not only the initial congestion window. So that's work that is going on. We wait for the QUIC, so we want to provide best current practice on at least make people aware of our use case when you do QUIC parameterization in your CDNs and servers. And if I'm here, it's to speak to you about the losses on the satellite terminal we have. So this is a real satellite gateway. We have a real satellite in the sky and satellite terminal, and we connect two computers. we don't have TCP split solutions. We have a 2 megabytes transfer, and we just induce 1% losses between these two, the satellite terminal and the end user. And what we see from our results on the left, you have the CDF or the page loading time of these 2 megabytes objects. And on the right, we have losses, 1% losses. And we can see that in our case, when you have in-sequence networks with very different characteristics that are not communicated to the server and are not server do not provide anything to mitigate these problems, we have 5 seconds increase in the medium download time. So that's and more than 80% for 80% of the cases, we have 18 seconds increase for the time needed to download an object. So to be fair, we have also considered congestion losses, because we know that they are not only losses that are due to the wireless part, but also losses due to congestion in the network. And so to be fair, we wanted to see the impact of congestion on these results. And what we have seen is that we have an increase in the downloading time when you have congestion, but it's a very less important magnitude than the Wi-Fi losses. So in short, this is an early work on quick parameterization. We have a draft. Collaboration is welcome if you want to help us. We think that maybe for the moment we want to focus on the satellite use case, but we think that having a best current practice on how you parameterize quick for wider internet is very relevant. So we still need further investigations, and that's just ongoing work. And to go back to one of the things we can do to mitigate these Wi-Fi losses, we often mention FEC. We know lots of people don't like FEC. So that's why we have been also following what has been done in masks this morning, when we think that wind transmission can occur between the satellite terminal and the end user. We don't know actually how all the implications on that, because I'm not a mask specialist, but we are looking at ways of improving this use case. So that's it.
Okay, thank you. Unfortunately, we don't have time for discussion, but thank you very much for presenting. Who has not signed up the blue sheet? Okay, also please look around. There must be another copy of them somewhere. I can see them. Great, thank you. See you in Singapore.
Thank you very much. Enjoy your cookies. Well done. I'll take the blue sheets. Yeah.